using the Euclidean algorithm to find the greatest common divisor. Example 1. Find the GCD of 334 and 162. So to do this problem, we're going to use the division algorithm. So 334, we're going to divide it by 162, and 162 goes in 2 times. So we get 2 times 162, and the remainder is 10. And then we're going to repeat this process using the 162 and the 10. So 162 is 16 times 10 plus the remainder of 2. Repeat the process again, now on 10 and 2. 10 is 5 times 2 plus 0. So we stop when we get a 0 remainder. And the last non-zero remainder is our greatest common divisor. So the GCD of these two numbers is 2. Now we're going to use the extended Euclidean algorithm to express this GCD as a linear combination of 334 and 162. So the first thing we're going to do is go back to each one of these equations and solve for the remainder. So 10 is equal to 334 minus 2 times 162. And 2 is equal to 162 minus 16 times 10. Okay, so now we're going to start with the last equation on our list. We're going to rewrite that, except we're going to take the 10 out and replace it with this new name for 10. So I've got 2 equals 162 minus 16 times 10, where 10 is 334 minus 2 times 162. And then we're going to combine like terms. So I've got 162 here, and I've got 162 here. I want to combine those two. So I've got 2, and here's 1 times 162, and then I've got minus 16 times a negative 2, so that's positive 32 times 162. So I've got 1 times 162 plus 32 more. So I've got 33 times 162 minus 16 times 334. And you can punch that into your calculator and make sure that 33 times 162 minus 16 times 334 is 2. And it in fact is. And then we want to rewrite it just so we have these two coefficients out front. So 2 equals 334 times negative 16 plus 162 times 33. And there is our final answer. Example 2. Find the GCD of 682 and 591. And again, we're going to use the division algorithm. So 682 divide by 591, it goes in 1 time, and the remainder is 91. Repeat the process on 591 and 91. 591, divide it by 91, goes in 6 times, plus a remainder of 45. Now we'll repeat the process on 91. 91 is 2 times 45, with a remainder of 1. Repeat on 45 and 1. 45 is 45 times 1 plus a remainder of 0. And again, the last non-zero remainder we got is the greatest common divisor. So the GCD here is 1. Now we're going to use the extended Euclidean algorithm to express the GCD as a linear combination of the two numbers again. So as before, the first thing we're going to do is solve for each one of the remainders. So 1 equals 91 minus 2 times 45. 45 here equals 591 minus 6 times 91. And 91 equals 682 minus 1 times 591. So now we're going to rewrite this last equation. 1 equals 91 minus 2 times 45, where 45 we're replacing with this. 591 minus 6 times 91. Now we're going to combine like terms. So I've got 91 here, one of them. And then I've got negative 2 times negative 6 times 91. So negative 2 times negative 6 is positive 12. So I've got 12 times 91 plus one more. So I've got 13 times 91 minus 2 times 591. Again, you can check your math. On your calculator, do 13 times 91 minus 2 times 591 and make sure that equals 1. So now we want to repeat that process. We've used the 45, and now we want to replace the 91 with this expression. So we rewrite it, 13 times 91 minus 2 times 591, where my 91 is now 682 minus 1 times 591. And now we're going to combine like terms again. So we've got 13 times negative 1 times 591. So we've got negative 13 times 591 minus 2 more. So we've got negative 15, or negative 13 minus 2, times 591. And we've got 13 times 682. Again, check the math on your calculator. Do 13 times 682 minus 15 times 591. Verify that is equal to 1. And lastly, we're going to rewrite it so that the coefficients are out front. We've got 1 equals 682 times 13 plus 591 times negative 15. And that is our solution. Example 3. Find the GCD of 299 and 191. This problem is going to be a little bit longer. 299 is equal to 1 times 191 plus a remainder of 108. Now we're going to repeat on 191 and 108. So 191 is 1 times 108 plus a remainder of 83. Now 108 is equal to 1 times 83 plus a remainder of 25. Now 83 and 25. 83 is 3 times 25. That gives you 75, so we've got a remainder of 8. Now 25 and 8. 25 is 3 times 8 plus 1. And finally 8 and 1. So 8 is 8 times 1 plus 0. The last non-zero remainder was 1. So the GCD of those two numbers is equal to 1. Now we're going to use the extended Euclidean algorithm again to express the GCD as a linear combination of the two numbers. So as before, we're going to start by solving for all the remainders. So 108 is 299 minus 1 times 191. 83 is equal to 191 minus 1 times 108. 25 equals 108 minus 1 times 83. 8 equals 83 minus 3 times 25. And 1 equals 25 minus 3 times 8. Okay, so now we're going to start with the last equation. 1 equals 25 minus 3 times 8. We're replacing the 8 with this. 83 minus 3 times 25. Now we're going to combine like terms. So we get 25 minus 3 times minus 3 times 25. So negative 3 times negative 3 is positive 9. So we got 125 plus 9 more. 10 times 25 minus 3 times 83. And again, check the math on your calculator. Make sure that works out to be 1. So we've used the 8, and now we're going to substitute 25 substitute for the 25, that 108 minus 1 times 83. So 1 equals 10 times new name for 25 minus 3 times 83. And the new name for 25 is 108 minus 1 times 83. And again, we're going to combine like terms. We've got 83s here and here. So we've got 10 times negative 1. We've got negative 10 83s minus 3 more. So we've got negative 13 times 83. And that first term is 10 times 108. Okay, so we're continuing up. We've got 2 more substitutions to do. Next, we're doing the 83. So we got 10 times 108 minus 13 times 83 becomes 191 minus 1 times 108. Combine like terms. We've got 10 times 108 minus a negative 13 times 108, or plus 13. So we got 23 times 108 minus 13 times 191. Again, punch into your calculator and check to make sure that works out to be 1. And we've got 1 more substitution. 108 becomes this. So we've got 1 equals 23 times 299 minus 1 times 191 minus 13 times 191. So we got 23 times 299, and then minus, we've got 23 times negative 1 times 191. So we got negative 23 minus 13 more. So negative 36 times 191. And we'll check the math to make sure that equals 1. And then I'm going to just rewrite it as 299 times 23 plus 191, my other number I started with, times negative 36, and that equals 1. And there's our final answer. So I hope that helps, and you have a great day.